and welcome back to physics class. I hope you had a restful holiday despite it being a pandemic. It's important to make sure that you get enough rest and take care of yourself during these hard times. With that being said, let's start delving into today's topic. So today we're actually going to start talking about actual physics. Physics is all about the study of movement and motion. And in order to understand that, we need to ask ourselves a couple of questions. Question number one would be, where is the object or person located that we are studying? Question two would be, are they going somewhere? Where are they going? And question three would be, how fast are they getting there? These are some of the basic questions that we are going to be looking at when we start talking about things like position, displacement, and velocity. So let's take a look at that first question. Where is the object or person that we are studying? The location of the object that we're looking at is called the position. And the position is often in reference to another position. So, for instance, let's say that I had this extension cord and I'm holding it above the ground. Now, what is its position in reference to the ground? Well, I am about 1.75 meters, so if I hold it at like my shoulder level, let's say that would be like maybe 1.4 meters, about something like that. So, but it's 1.4 meters from the ground being my reference point. My reference point is often 0. That makes it easier to figure out the position of something. So what's my position compared to the ground? Well, I'm standing on the ground. So my position would be 0 at that point, since I am on the ground. If I was standing on this table looks like it's like under a meter, like maybe 0.8 meters. If I was standing on the table, or if I was sitting on the table like this, then I am now 0.8 approximately meters above my ground, above my reference point. So that is position. Position is the location of an object in reference to a reference point. Now let's take a look at that second question, is where are they going? So when we look at where they're going, we are considering the starting point where they started, and we're considering their end point where they finish, when they finish their movement. So that means that there's a change in our location. It's a change in our position. And that is called displacement. Displacement means a change in position. Now, if let's say my starting point was right at the edge of this table, and I walked over to this other table. Well, that's approximately it's a little bit less than 1.5 meters, I would say. So let's just say that in that space, my displacement was 1.5 meters. Now, if I went from here and I went back to my starting position, then from there to here, it would be negative 1.5 meters. The reason it would be negative is because I went backwards. So displacement is a vector quantity. And because it's a vector quantity, that means direction's involved, which means that you can have a negative displacement. Now, if we took my entire displacement, starting from here, moving over here, and then moving back, I started and finished at the same position. That means that there's no displacement. So it's possible that even though someone has moved, their displacement will still be 0.
Now, displacement has a formula associated with it to help us calculate our displacement. And the formula is as follows. Delta x is equal to xf minus x naught, or x0. Now, delta x just means displacement. Specifically, x is your position, and the delta means change. So delta x literally means change in position, which is our displacement. xf is your final position. And x naught, or x0, is your starting position. Now, when we look at displacement, we always consider our final position, and then we subtract our starting position from that. Let's take a look at an example. So let's say we have a cliff overlooking the ocean, and there's a boulder on the top of the cliff. Let's say that the height of the cliff above the ocean is 8 meters, and the ocean is 15 meters deep. Now, if this were to fall and fall to the bottom of the ocean, what is its displacement? So, displacement, we want to look at the final position first. Now, this is our 0 point right here. This means that the position of the rock at the bottom of the ocean would be negative 15. And then we're subtracting the original position, which is the starting point, which was positive 8 above sea level. Now, when we calculate it, we end up with our final displacement of negative 23 meters.
Now, when we're talking about movement in between two places, we also have this concept that you are probably very familiar with, and that is the concept of distance. Now, distance is completely different from displacement. Displacement is a vector, therefore it has a direction. Distance does not have a direction. It's just a length, essentially. So if we were to look at the example where I'm traveling from one desk to the other and then I go back, we know that my displacement is 0 because I started and finished at the same point. My distance, however, would be a number that is greater than 0. If I walked 1.5 meters and then walked 1.5 meters again without considering my change in direction, then I have walked a total of 3 meters, and that is my distance. So, distance does not take into consideration direction, and it is just the total amount of movement that an object or a person does.
All right, so let's take a look at a distance example. So let's say that we have this kid named Dave, and Dave lives a certain distance away from the school that he goes to. Let's say that he lives 2.5 kilometers from the school. Now, let's say that Dave decides to walk to school, and he walks until he reaches about halfway before he realizes that he forgot his homework. And he has to run back home to get his homework, and then runs all the way back until he reaches school. So, what is the distance that Dave traveled? Well, let's take a look here. We know that he traveled halfway. So what's half of 2.5, right? 1.25. 1.25 kilometers. He traveled that one way, and then he traveled that back to go home. So 1.25 kilometers. And then he traveled the full 2.5 kilometers to get to school. When we add all of this up, we will find that our total distance that he traveled is 5 kilometers.
So that's all we're going to talk about today, folks. I will see you next time when we start delving a little bit deeper into these topics.